Welcome to another episode of the AMP podcast. I'm your host, Sammy Miles, Managing Editor-in-Chief of Corrosion Journal. Today, I'm excited to welcome Lucrezia Scopio, Dr. John Scully, and Dr. Nick Birbilis. In this episode, we're going to focus on AMP's award program and some of Nick's achievements as he is honored with the 2026 Willis Whitney Technical Achievement Award. So we're going to start with some introductions. If you would, please briefly introduce yourself with an overview of what you're doing today at your employer or anything else you want to mention. Lucrezia, why don't we start with you?
Oh, hi. Good morning, everybody. I'm Italian. I've taken my master's degree in chemistry at the University of Rome in 1995. I'm now an independent consultant operating in the field of material and corrosion engineering. I'm involved in material spec for OCTG and downhole equipment, and I've been with NACE AMP for 35 years, occupying different positions, and actually I'm the award committee chair. Thank you, Sammy.
Wonderful. And John, over to you.
Well, thank you, Sammy, and I'd like to thank everybody for being here. This is a great occasion. I'm John Scully, and I'm a professor in the University of Virginia, Department of Material Science and Engineering, and I'm a co-director of our Center for Electrochemical Science and Engineering, which mainly does corrosion these days. I'm also the state or governor-appointed director of the Nuclear Materials Reliability Center in the state of Virginia. As far as I've been a member of AMP for a long time, before that NACE, so I don't want to say when, but back in 1982 or so. And I'm currently the editor-in-chief of Corrosion Journal, but in the capacity that I appear today, I have the distinct honor of being the task force leader or task force chairman of the Whitney Award. And so I do research, and my main output is patents and PhDs and papers in the corrosion area. So thank you, Sammy, for asking.
Thank you. And Nick, finally you're up.
Thank you, Sammy, and what a pleasure to be here. I'm Nick Birbilis. I'm Australian. I studied in Australia, studied engineering at Monash University, and then fell into, the area of corrosion, which we're going to talk about a little bit today. In my current capacity, I'm a professor at Deakin University. I'm based in Melbourne, in Australia, and I'm with the Faculty of Science, Engineering and Built Environment there. I also do research in corrosion and materials durability more broadly. In addition to that, John just reminded me of our strong relationship, with AMP and NACE before that. So I've been a member for 25 years and time really, really flies. But actually, I think careers are somehow inexplicably linked with AMP over the years. And through that, I've been engaged in a lot of different things, having been chair of the research committee, various editorial boards and so forth. So real pleasure to be here speaking to you today, Sammy.
It's great having all of you. Now, Lucrezia, is there anything new in the AMP Awards program this year? And can you share some highlights of the 2026 award winners and events taking place at conference?
Sure. Thanks, Sammy, for asking. The number of award categories is increasing every year, bringing forward new ones, so everybody can feel to belong to the organization. The AMP Award program recognizes members at all levels, from engineering, scientists, educators, technicians, and laborers. We don't have only the prestigious Whitney Award, that of course is our scientific merit flagship award, but also several others. There are awards at both academical and industrial level, covering also early career stage of our members. We had so far 23 different award categories, which are administered by task force group leaders, and each task group is structured with several committee members. The nomination packages are evaluated by the task force and discussed and then reported for approval to the award committee. This year, we introduced 2 new awards that speak directly to who we are as an association. The first one is the Craftsmanship Award. This award recognizes individuals who demonstrated high skill in execution, identification, and prevention of corrosion control. This individual demonstrated professionalism through natural talent, passion, dedication, and determination to deliver a superior product. By establishing this award, we affirm that hands-on expertise and technical mastery are not only a simple value at AMPP. So this represents a skill and pride in the daily commitment to doing the job right. We also introduce another award, which is called Robert Baboyan Successful Innovation Field Application of Corrosion Technology Award. This honors a field practitioner in corrosion control and technology who demonstrated excellence in execution and the creative use of state-of-the-art techniques. These awards recognize successful completion of work addressing particularly difficult or pioneering field application of corrosion diagnostics, which have safeguarded historical metal artifacts through innovative and long-term preservation strategies. So innovation does not only exist in research and design, but lives in the field, in the real-world environment, often under demanding conditions. Together, this new award reflects the full spectrum of our membership. So they highlight the different diversity in role and expertise and contribution that strengthen AMPP and position of our community. Going to the event taking place during this conference, we have, first of all, Tuesday, March 17, the Fellow Breakfast, when the new Fellows members will be introduced to the Fellow community. And then on the same day, Tuesday at 9 o'clock, we will have a Whitney lecture hosted by John and given to us by Nick at 9 a.m. Then we have the following day, Wednesday, the Student Poster Award ceremony. This will take place at lunchtime. This is also another very important appointment that we had at the conference. And so many fellow members participated and helping us in selecting the best posters. On Wednesday, there will be the evening celebration of all the awardees, so what we call the honorary night. And we will have again the pleasure to have Nick that will give also a speak to us. So this is all for the moment.
Wonderful. And I want to focus a little more on the Whitney Award. John, the Whitney Award is usually considered one of AMPP's flagship awards. Can you provide some insight about the award and what really stood out about Nick's candidacy for it?
Sure, Sammy. Love to. So the Whitney Award is the premier award of the society, and it's a Lifetime Achievement Award for a lifetime full of work and sustained contributions. And it's reads significant contributions to corrosion science through fundamental understanding of corrosion phenomena and prevention. But it also could be qualifying through education or work that leads to better understanding materials protection using scientific methods. And, when I say sustainability, it's not just one thing. There are wonderful awards, as Lucretia has mentioned. There are technical achievement awards, for instance, for specific technical achievements. But the Whitney Award tends to be for lifetime achievements in a certain area. And the case is really honored here to present that award in connection with Nick Birbilis, who's checked every box and done everything, but not just quantity, has done it excellent. So it's a meritorious award that isn't, there are awards that are, and they're well founded to be based on service, or you can raise your hand and apply to a committee. It's not something you can do for the Whitney Award. You basically earn it through a lifetime of scientifically appreciated work that sustains itself, that's actually, sort of there for a long time before people turn the page and move to the next idea. And so it really highlights the scientific achievements and things that are enduring. So with that, I think I'll stop and let you go on, Sammy. But that's the award. We're very excited about the award all the time because it's an international award, doesn't require AMP membership. And so we're completely open to people that aren't regulars, let's say, in AMP. for those scientific achievements. And the committee that I've assembled is all international. It's actually 4 people from 4 different countries and a chairperson. The chairperson doesn't even vote. I don't vote, only on tiebreakers or things like that. And so you have basically selection from around the world, in this case, Australia, but you also have deliberation and from people that have different perspectives. They're not all from one region. And so we're very proud of that. And the whole thing just, is a great thing. And I'm so thankful that AMP supports this award and the awards committee. Thank you.
And Nick, can you share a little bit about your career journey with our audience from where you started to where you are today?
So, Sammy, that could be a long response, actually, now reflecting on what John had mentioned and what feels like a whole lifetime. But look, I'll try and be short, I guess. Journey from where I started to where I am today. So I apologize to the listeners, but I'll go back a little bit. But look, like many students, I'm going back to my teen years now, when you're interested in STEM or science and technology, you typically tend to want to study engineering and explore the world through, I guess, numbers and learning. So after high school, I decided to study engineering. So I'm going back a little bit now. But look, thereafter, I think once you start studying, careers are usually forged by a combination of luck and decisions, right? So there's some decisions I made, but there's always a heck of a lot of luck in where you end up and the people you meet along the way. So at university, at Monash University in my hometown of Melbourne, I chose to study material science and engineering, and that was largely driven by a fascination of materials. And that fascination is really still there, Sammy. What specifically, felt exciting about materials is that it was a really intriguing domain, almost like a black art. You have these invisible structures within materials that you can't see with the eye, but they control the properties of really large things. And I mean, they control the properties of how light your car is or how strong your car is, but also bridges and aircraft and really, really large things. And that happens at the nanoscale or even the atomic scale. So being able to potentially control the properties of large things by invisible things, I thought that's something that's really interesting. And I knew that it would make a lifetime of really interesting sort of dinner table conversation when you can talk about things that are pretty cool that no one can ever see. But luck, as I said, is really important, Sammy. And I was lucky to be at a university where there was a number of academics working in corrosion. I think not all universities have that luxury. We're fortunate, and certainly across AMP, we see and get to interact with a lot of universities that really are looking at materials protection and performance. So that bit was lucky. There was a couple of academics working on corrosion, and I was fortunate in my final year to be able to take a course on corrosion and learn about it. And I thought, oh my goodness, this is really cool. But I think the biggest bit of luck is that I was able to select a senior project when I was finishing, the engineering degree on corrosion. And I managed to be able to select a project which was an industry project working with a consulting company here in Australia, where they wanted someone to investigate the deterioration of a marine structure. It was a structure out in the bay, so salt water. You can already tell corrosion's going to be a problem. So the salt water. It was a reinforced concrete jetty, which is a large structure where large ships can come up and go, up against the jetty. And in this case, it was a fuel unloading jetty. So a really big structure to have a young kid go out and monitor. So I had to go out and learn how to do things like LPR measurements on site and assess, is this structure corroding? And then as we got to the end of these measurements, the consultants wanted to know, well, if it's corroding, what are we going to do about it? So it's kind of thrown literally in the deep end. And I joke about that because doing these measurements, I had to go out in a boat and do them standing in a boat. And I would often have seals trying to get on the boat and so forth. I'm sure many of the listeners know about seals, but times were different then. But really, that experience did a couple of things. One thing is that I realized this is hands-on and corrosion is a combat sport. And I really, really love that. It's very different to other bits of engineering. But one thing that I'd share as a sort of a personal thing is through that experience, I've almost felt like a doctor, not a doctor of medicine, but a doctor of structure, and structure as a doctor of things and so forth. And I know a lot of other colleagues do, because sometimes you'll hear jokingly people call even folks like John or Lucrezia, Dr. Rust or something like that. We've decided to work on the ailment that is corrosion. So through a bit of luck and some choices, I did something that I found really, really interesting. In fact, one of the hallmarks, I guess, of working on corrosion, that I only realized after being in there in some years, but I know that's what's kept me in corrosion for a long time, is when you work in this area, it's usually a chance to work on lots and lots of small projects. And I mean, they could be large projects, but short or finite in time. So you'll get to work through your career on, a deteriorating building. It might be a material that's not performing in a pipeline, an aircraft, a military item, whatever it is. And that collection of really, really small things keeps you interested and engaged and keeps you really, really, really learning. But I guess the question was how I got to where I am right now. So I was going to say I had a couple of failed attempts at industry, but I wouldn't call them failed because I've worked with industry my whole career, and you can't really have an impact unless you're working with industry. But after graduating, I started working in industry for a company locally called Mornsel that was ended up now becoming part of a big American company called ACOM. And I thought, this is so much fun. I want to learn more about corrosion. I just don't want to apply it. So I went back and did a PhD, which was really exciting. And as you can imagine, I went out into the workforce again, and I thought, I really want to still work at the forefront. So I jumped into academia, because in industry you get to apply a lot of things, but I wanted to be at the forefront. And I realized you can't really be at the forefront unless you're partnering with industry. So I see my whole career as being 1 foot in industry and 1 foot at the sort of lab bench. And like many others in our area, a whole number of the papers and outputs we have are co-authored with industry and trying to make a real impact, which is why corrosion is so relevant. But then after abandoning industry, I thought, how do I get into academia? And that's where the USA has played a really big part. Things were different then. I mean, this was bordering on last century now, but you would apply for things differently. Things would happen through envelopes, and you'd send things and you'd type a CV and so forth. But I applied for a postdoctoral position at a university that's not very well known, or at least not at the time, over here in Australia. So I applied for a postdoc at The Ohio State University in a town called Columbus, Ohio, which I hadn't heard much of before then, having grown up in Australia. And I was fortunate to be able to work there in what was or still is, the Fontana Corrosion Center. And I guess from there, the rest is history. That was a real great opportunity to work with wonderful people. I worked with Rudy Buckheit, a little bit with Jerry, and many others that have now, over the last few decades, been there. But it was wonderful to be at a place where there was a collective of people working on corrosion, and it sort of let me meet lots of other people at other universities as well, where there was collectives working on corrosion. I think at the time, University of Virginia had a very big group. They still do. Penn State had a big group. So there was little centers of excellence in corrosion where you could start to form communities and so forth. And I thought, that's my tribe. That's what I want to be doing. I ended up coming back to Australia, where I've now been for a really long time, to start an academic career here. And that what I tried to do was emulate quite a lot of what I've learned in corrosion and build, in the US, and build sort of communities and communities of practice and bring lots of people together to work on, I guess, this ailment that is corrosion. But anyway, now I'm yapping. It's a really long answer to a really good question, but I think the combination of luck and decisions, and I haven't regretted a single day. I still feel like Dr. Rust. Some days are better than others, but what we do know is every next day there's going to be a new challenge for us in corrosion.
I think that's a great story. And I think calling people Dr. Rust, I've seen people called rust busters and things like that in our industry. I love all those terms out there.
Yeah.
And
there's a lot of funny terms, Sammy. I don't mean to cut you off, but I mean, one of the ones that I'm sure will come up at the conference is that alcohol is a really good corrosion inhibitor. And there's so many funny jokes around corrosion. But anyway, this is not the time for those.
well, I kind of want to build off of, your career and where you've gotten to. And are there anything that stands out that you've worked on over the year? Do you want to highlight anything, any projects, anything like that?
Wow. it's going to be impossible to pick one, Sammy. So I'm sorry, I'm going
You
to
could do several.
babble a little bit. But, as I was saying, when you get to work on lots of things through a career, you have so many highlights. And I think it's hard to pick one. There's lots and lots and lots of highlights. The obvious ones that are a highlight, collaborations, I think clearly you can't get much done unless you're working with others or working with teams. So one of the biggest highlights is being able to work with people all over the world in a really sort of agnostic way. I think, time doesn't matter, politics doesn't matter, geography doesn't matter. Corrosion is one of these things that strikes the planet, with the same level of attack. So being able to work with people all around the world has been a really big highlight because everyone brings different things. And of course, the other highlight, before I get into technical things, is the impact that our work can have. So I find I'm often explaining to people that haven't really heard of corrosion or what it is as an industry over and over again. And that's good. I enjoy it. And one of the things that I tell them all the time is, this is something that's 3 to 4% of the GDP. If you turn that into numbers, it costs every person, in most countries, thousands of dollars every year, and you wouldn't think so. But I might get these numbers a little bit wrong, but I still think they're correct to me. But the other thing that I mentioned is that the size of the corrosion problem, the 3 to 4% of the GDP, is about as big as, say, industries like the automotive industry. I think that's somewhere 3 to 4% of the GDP, and that's well known to everyone. Or the entertainment industry, Hollywood movies. And so, people know about their car and they know when they get home, they chuck on the TV and they know what they see. And in parallel, you've got this really same sized gargantuan thing going on that no one talks about. And so what's also a highlight is that it's so big and our work can genuinely have a true impact. And I'm glad that through things like this podcast, we can remind people how important it is, because a passion of mine is to see it diminish as a problem. I think we're a long way from there, but it'd be good to see 4% of the GDP turn into 3, turn into 2, turn into 1, turn into 0, and then maybe our work will be done. But in your question, so what are highlights? I'm going to go back to my analogy of a bit of luck and a bit of decisions. But the first, I guess, really detailed bit of work I worked on was when I was a postdoctoral researcher at Ohio State, where I got to work on a program looking at the structural integrity of aircraft. This program had, again, lots of industry partners. A big one at the time was Northrop Grumman out in New York. And what I realized at the time, it was a really special time. Through the late 90s and the early 2000s, characterization of materials really accelerated. So a little bit of, when I say luck, a little bit of being in the right spot at the right time. Some years before I got to Ohio State, Rudy that I worked with, and of course John at Virginia, but also previously, had done some really interesting work trying to relate, I guess, the microstructure of alloys to their corrosion performance. This sounds so routine and mundane today, but even in the late 90s, it took really the advent of, I guess, high quality scanning electron microscopes, these ones known as field emission microscopes, to be able to look at microstructures of alloys in the sort of resolution and I guess quantification. You can say, here's this feature in the microstructure, and when that's in the microstructure, here's what happens to the corrosion. So I see the late 90s, early 2000s as being the start of an era of sort of determinism. So being able to actually start to be able to unravel what structures do to properties in corrosion. And there's several, if you look back in the annals of history, there's several Whitney Award winners actually that were there from the very, very beginning of that. John being one, many others in many areas, Sridhar, lots of others as well. And I could go down the whole list actually. But determinism was the name of the game. So being in the right spot at the right time, and with these microscopes sort of emerging in parallel, I guess a big chunk of my career early on, and it's sort of maintained, was forged on sort of coupling advanced characterization with corrosion properties. And that started in aluminium alloys, or as they're known there, aluminum alloys, and looking at what microstructures would result in terms of corrosion. That is a real highlight, because you actually go from being able to sort of estimate what might happen to being able to deterministically sort of dial up ground truth things. And then on that basis, I guess, one thing that really fascinated me was the unknown. I still feel gobsmacked sometimes that in the world we do a lot of things and we accept a lot of things and we don't know where they come from or what the background is. So at the time, and I'm not going to sort of talk too much about specific scenarios, but at the time we were looking at alloys that were in aircraft that had been flying for a really long time. And it was fair to say that we didn't fully understand these alloys, even though they'd be flying people around the world for decades. And all the topics around that really fascinated me. And one of the things that fascinated me is that we were flying jet aircraft around without understanding really fundamental relationships, like even the role of grain size and how it impacts corrosion, when we knew what it would do on strength and other things, many decades earlier and so forth. So I guess, over the 20 years after that, through various projects and various partners in various locations, it's been a real highlight to unravel the effect of different structural features and how their size, their shape relates, how grain size relates to corrosion and all of these things. And you're probably wondering, that's a good academic endeavor, but every result has been a lot of fun. Everyone I've got to work with, and in my case, sort of train postdoc students or partner with at other unis, every one of those days has been a highlight. But it hasn't just been for the sake of academic endeavor. What we've been fortunate to do is use that knowledge and turn it into pragmatic solutions. So another bit of fun has been, can we use this knowledge to design or develop or modify alloys to then put them in service with enhanced durability? And the answer is yes. Certainly with aluminum alloys, we've continued that legacy in a range of different alloys that are used in sort of marine or lightweighting. I won't name those applications because you can probably guess what they might be. But in magnesium alloys, which is even lighter, it's been wonderful to be able to translate these learnings into commodity products. So for many of you, if you have a certain brand of phone that has a magnesium alloy chassis, it's highly likely that the alloys in there were developed by my group or collaborators. Or if you've got chassis on, say, your motorbike or your laptop casing or something like that, the alloys that are involved there are things that we've been able to work on and dial up so that they can go the distance in these sorts of products. And that's continued with time. In my case, staying at the forefront of characterization and again, alloy development, that's evolved to work on 3D printed alloys, and with more collaborators, this sort of new area of high entropy alloys, and now even working in AI. So hand in hand working with technology to try and improve what we do in determinism has been, I guess, the nutshell. Sammy, I'm sure I've left out a million things, but I do want to, reinforce that every day has been fun because it's been about exploring the unknown and doing that with others. What could be more fun, I guess.
I think that's a great highlight and very inspirational for people earlier in their career on things you can do and which routes you can go.
Yeah, yeah. So, Sammy, I forgot to say one important thing because sometimes I don't qualify things. Like, it sounds like I've done everything. It's definitely not the case. I think another thing that excites me every day is being humble and having humility to see what others do. So, all the examples I've talked about, they're probably relevant to things like sort of maybe transport, aerospace. But I have to confess, I've never worked a day in nuclear. I've never worked a day in high temperature. And I just did want to reinforce that corrosion is so large. It's like saying the word, food. There could be someone that makes the best, apple pie, but they're probably not the person you want cooking your steak. And so the stuff that I do in corrosion, I feel like I'm only scratching the surface, but it is great to look back at previous Whitney winners and other winners of different applied awards. And they're working in really important areas that I will confess I have no idea about. We have no nuclear industry in Australia, and nothing there. Very little high temperature, like I said. I haven't worked on areas like copper alloys and things like that as well. So I still feel like there's lots to do. And I'm glad that there are others that are equally quirky and geeky like me working on other areas that they find fascinating, because it really does take a village.
And on that, what does receiving the Whitney Award mean to you?
Oh, wow.
In the context of all the past winners that you mentioned.
Yeah. I wish I had the time to prepare, but I mean, the first thing I think that it means to anyone is, given the history of AMP and the societies that sort of precede it and the number of members, nearly 50,000 members or 40,000 members. Firstly, it's a huge honor, and there's a deep, deep sense of gratitude. I mean, to sound geeky, the gratitude is kind of like a four-dimensional thing. I say 4D and it's geeky because the fourth dimension is time. And when you look back, there's a sense of gratitude for those that have previously won the award and the profile that they've been able to give the award. So I'm really, really grateful. But secondly, it means for me a chance to really reflect on my career and reflect on what having recognition like the Whitney Award can do. And actually, that's the bit, it's equal part humility and gratitude. And I'm so, so grateful and honored. But the bit that scares me is I see it as an important call to action. I think, having that sort of profile means that stewardship and using the award as a platform to engage others, alert others about corrosion, alert others about what we could be doing, whether it's designing differently, whether it's learning more about corrosion, whether it's training others, whatever it is. I get a sense that the next part of my career now is going to remain even busier, because using this as a way of highlighting the challenges in the corrosion field and getting people sort of jazzed up is going to be a really, really big part. So it means lots and lots and lots of different things to me, but I'm not going to underscore the gravitas of this. It's named after someone that had a distinguished career from the get-go, Willis Whitney, and played a big role in the industrial world as we now know it through, running the GE labs, propulsion, energy, light, the whole lot. It means something particularly special to me, and this is why I want to say a big thank you now while I can. I'll say it over and over again, that AMP is truly international as well. So the fact that folks can be recognized outside of the USA, and there's a long history of recipients outside the USA, I think also speaks volumes for this being a global issue, speaks volumes for AMP always having that international outlook, and certainly before that, SSPC and NACE International was in the name. And so for that, I think this is a chance for me to be able to talk more and more about corrosion for the next 20 plus years and continue to fly the flag. So a big thank you to AMP, but also all those involved in the selection and the recognition.
I'm going to pivot slightly and go over to Lucrezia. The 2027 call for nominations will open a little later this year. Can you provide our audience with some information about the nominations and the timeline so that people can be submitted for the next Whitney Award for 2027 and things like that?
Thanks, Sammy, for the opportunity to mention it. Regarding the schedule, I can confirm that the launch of the 2027 program is June 30, and we will have some months, and the nomination will close on September the 30th. I know that everybody can participate and nominate somebody if he feels that needs to be recognized. The primary goal is to recognize individuals or companies that have significantly advanced understanding of material protection through corrosion control, and in particular regarding this Whitney and all the other awards. So I hope that we will get very good nomination from all over the world. Thank you.
Wonderful. John, do you have any advice for those who are putting together nominations for the Whitney Award? And what type of qualities stand out about the candidates when y'all look at nominations? I know you say you don't have a vote as the chairman, but what types of things is the committee looking for?
Well, I can say it in 2 words: that sustained excellence, and a few more words: sustained excellence in corrosion that's had a big impact on the corrosion field. And Nick's led several careers in one lifetime, in my opinion, Nick. And so there's other things too that Nick has been a thought leader in different alloys, magnesium, aluminum synthesis. So just think in terms of the AM, artificial or additive manufacturing, these multi-principal element alloys. And so he's kind of interesting the way he spun the story, that he started off looking basically at structure-property relationships, knowing the structure was like nanostructure. And so it was really challenging at first. And then he went so far and was so spectacularly successful in that. And, what are you going to do for an encore type of thing? Well, he did. He was one of the leaders in artificial intelligence, and doing artificial intelligence before everybody was doing artificial intelligence was one of the ways I put it. And so, there were so many variables, but the way I put it in the context of his description, there were so many variables. You couldn't just isolate one variable, one culprit, right, Nick? You had to basically do artificial intelligence to help you sort it out. And so for other people, back to your question, which I didn't answer, is, think of the multiple success stories that you have, that a person's had. Like, it's great that we have people that have like a, one-time breakthrough. Don't get me wrong. That's wonderful. And there's all kinds of ways to do that. We could have a coating that, protects a new alloy, or whatnot. And those definitely are achievements, but something where you've changed the field. Like in Nick's case, he didn't mention, and I'll mention it, but he's had some stellar students. In fact, 2 of his PhD students are on the editorial board of Corrosion Journal. And they're, one is in France and one is in India. So it just goes to show that we, the society just benefits from people like that. And we'd love to see more people in this as an advocate for the corrosion community, as Nick described. And so I think in a package, you want to think not in terms of 1 or 2 things, but think in terms of several things. You want to think in terms of sustained impact. And a lot of people have good things they don't consider, but that's right. It was sustained in some way. Maybe the baton was passed in the laboratory to someone else, but the thought leadership has not been transferred, and Nick's got it. And so people that accumulate those kinds of things, stories to tell over time in an application, tend to be the most successful. And, it's heartwarming for me, I should say, that there are very, very good nominations. And every year it's amazing, how many people there are on the list. And that's pretty hard. It isn't like in dozens, but I'm just saying that it's just phenomenal number of good people around the world. And that's heartwarming that they would come to AMP and receive this award and embrace the society. And so just think long term, think of the sort of integrated sum of what you've done and what the impacts have been. And don't be shy about thinking about what they are, because the impacts could be the people. They could be, in one case, maybe it's the hardware. A wing doesn't fall off, to exaggerate, right? In the other case, it's entirely the group of PhD students that Nick put out, or the undergraduates that he taught, and was inspirational enough that they didn't get their PhDs, they didn't want to, but now they know when the red flag goes up on something like his concrete structure. They know the concrete structure in saltwater, that maybe a little light bulb ought to go in your head, right? And those are people that are just as valuable to educate, I'm sure Nick would agree, as the ones that are PhDs that are prestigious universities that are helping us with publications, right? There's all sorts of ways, right? You can fight the corrosion battle.
Yeah.
Well said. As we get ready to wrap up, Nick, if anyone wanted to reach out to you to congratulate you and learn more about your career, what's the best way for them to do that?
Oh, thank you, Sammy. I'm not sure how quickly we'll syndicate this, but I will be there in Houston for the big show, the AMP meeting in March. However, email works tremendously well. I love hearing from those in the corrosion community. So email is an obvious way. So if you look me up, you'll find it very quickly. I also tend to use LinkedIn a lot. It's a way that I can continue to sort of learn on the fly. So that's another way to engage with me, and more broadly, with the corrosion community at large as well. There's some really nice activity going on there. So yes, I hope to hear from lots of you, and can't wait to do so and engage with you as we keep fighting the corrosion battle.
And John and Lucrezia, is there anything else y'all want to add before we wrap up?
No, just congratulations, Nick. It's well deserved. And
congratulations, Nick. Well deserved, really.
Thank you.
And with that, thank you for listening to our AMP podcast today. And I'm Sammy Miles. Again, I'm here with John Scully, Nick Birbilis, and Lucrezia Scopio. And we look forward to seeing some of you in Houston at AMP Annual Conference.
Right. See y'all in Houston.